Hello, grade 10. Okay, here we go with our last circle theorem. So this one is called angles in a cyclic quadrilateral, okay? Quadrilateral, you know, is a four-sided shape. Cyclic means that it's right on the circle, all 4 points. We've already seen it. We see that the angles that are on the opposite ends of the arc, one in the major arc, one in the minor arc, will always add up to 180 degrees. You see, so I can change this as I want. Those opposite angles are supplementary, is the formal word for it. This is actually quite easy to prove. Do you remember from before with the Star Trek theorem, we saw that the angle at the center is twice the one that is on the arc. So here, if this is A, then this is going to be 2A, and if this is B, then this is going to be 2B. Well, look what happens. Look at the center only. We have 2A plus 2B completing a circle around a point, so we know that this is going to be 360 degrees. Simplifying that, we get A plus B is equal to 180. So there's your alpha plus beta equals to 180. Nice and easy. Let's just apply it to a couple of examples. And this, by the way, is now on page 25. And now this is going on to page 26 of your packet. So do follow along. And I'm just going to try a couple of the trickier ones right away. So for example, let's see something like this. And again, we may have to use a previous one. Well, if this is 140, I can't determine that, okay? These do not make 180. They both, remember, cyclic quadrilateral. So we know that C plus D will equal to 180, okay? What do we do? Well, remember your Star Trek. If this is 140, then C is going to be half of that, yeah? Angle at the center is always double the center on the arc. And then from there, if this is 70, then D is going to be 110. Not too bad, right? Which other ones could we do? What's a good one? Maybe this one. Okay, and again, there might be temptation for you to just take this and make this... this actually you can. This is just going to be half of that. But we can do it in a little bit more complicated way. Why not? So if this is 254, perhaps you can see that this is going to be 106, because together they have to make 360. And so from there, I'm just going to draw this line, and I can now use my Star Trek theorem, and I'm going to get this to be 53. Can you see that? Okay, well, wonderful. Well, if this is 53, then I'm going to use my supplementary property, and now I have a cyclic quadrilateral. 1, 2, 3. It means each point has to be right on the circle, and these now do have to be supplementary. So my B is going to be 180 minus 53, which is 127. Now you see that it actually does end up being half of this. So this is a convex Star Trek theorem, but this may have been a little bit difficult to see. So you can see that sometimes adding line helps. You kind of have to see what works. Okay, so you go ahead and try the rest, and that's it for circle theorems. Woohoo!